Welcome to Core Science. Today we are going to solve a physics question on motion on an inclined plane. Let's take a look at the question. A ball X is left to roll down an inclined plane of length 150 meters of inclination, 35 degrees. Just at that moment, a second ball Y is pushed up the plane with a velocity of 40 meters per second. The two balls meet on the plane at a point P. If the velocity of x is 3.6 times that of y at the time of meeting, calculate A, the velocity of x and y when they meet, when the two balls meet, where the two balls meet. Good. So this is the question. You can copy it down as we go through. Okay, without wasting my time, let's look at what we can get from the question. What can be deduced from the question. Entire length on plane is 150 meters. So that's our S. Let the distance traveled by ball X be Sx. Distance traveled by ball Y be Xy. But you see, since the overall is 150, you can just get it by subtracting the other side from 150. So that's what we've done. Initial velocity of ball X, Ux is equal to 0. Why? So from the question, the ball was left to roll down, meaning initially it was at rest. So the initial velocity was 0. It was at rest before it was left down. So it was being held down by someone. So the ball was having no velocity. Like the initial velocity was 0. I hope it's clear. Yeah. Okay. Then Uy is equal to 40 meters per second. So from the question, it was pushed with that velocity 40 meters per second. So it had that initial velocity. Let's move on. Angle of inclination 35 degrees. Let time taken by ball X and Y be Tx and Ty respectively. All these will be used in our workings. Let's visualize it. So this is it. Ball X, ball Y. Ball X, ball Y. And the from here to here is 150 meters. This is our axis which we mentioned here. And the angle here is 35 degrees. Let's move on. So we'll be using this. Okay, so the first part of the question, calculate the velocities of ball X and Y when they meet. Calculate the velocities of ball X and Y when they meet. We are going to use the first equation of motion on an inclined plane here to find the velocities. That will help us a lot. Okay, so let's do that. So for ball X, Vx is equal to Ux plus GTx sine theta. Here the acceleration due to gravity is positive because it's moving downwards, and you know acceleration due to gravity, Earth's gravity acts downwards. Acts downwards. So if you're also going downwards, it will support you. So here is positive. But Ux is equal to 0. So let's put that in our equation. It means Vx is equal to 0 plus GTx, and you know it's the same thing. So Vx is equal to GTx sine theta. Very good. Now for ball Y, so we found an expression for Vx. Now for Y, let's see. Here Vy is equal to Uy minus GTy sine theta. Why is it minus here? You see, this one is going upward. So it's being opposed by Earth's gravity because it's acting in a direction opposite. I hope you get it. An opposite. In life, everything opposite becomes negative for you. So negative gene, that's what we have there. But Uy is equal to 40. Vy is equal to 40 minus GTy sine theta, where theta is the angle of inclination. Now you see here, where we have the Vx is equal to GTx, we're able to make GTx sine theta the subject. Let's try and make this also the subject and see what we'll do. to help us a lot. Let's see. So to make that a subject, we'll move it to the other side of the equation, the left hand side, and it becomes positive there. You know that. Then we'll bring the minus the Vy to the other side. So we get dty sine theta is equal to 40 minus Vy. Now, Tx is equal to Ty. Why do we say this? The time taken by both balls will be the same since they started their journey at the same time and they met at the same point. Meaning the time this one took to get to that point P will be the same as the time taken by ball X to get to the point P. Please, I hope it's clear. We all take off at 10 a.m. in the morning. We are supposed to meet at a place. We met at the same time. We met at the same time. Means we travel the same time, right? That's it. So related to the balls. Okay, dtx sine theta is equal to dty sine theta. Since tx is equal to ty, we know that tx is equal to ty. So we can relate vx and 40 minus vy too. So Vx is equal to 40 minus Vy. This is equation 1. I hope it's clear why we have this. Okay. From the question, at the time of meeting, the final velocity of Vx was equal to 3.6 times that of ball y. So this is our second equation. Now put 2 into 1. So 3.6 Vy is equal to 40 minus Vy. Make Vy the subject. How? So send this Vy to the other side. You get 4.6 Vy is equal to 40. What do we get? Vy is equal to 40 over 4.6. So when we compute this, we get Vy is equal to 8.7 meter per second. I hope we are through. Good. Now we found one of them to help us find the other. So let's see. But Vx is equal to 40 minus Vy. So we get that from here. Okay. And Vx is equal to 40 minus 8.7. What we got here? Good. And what's our answer? 31.3 meter per second. So we found the velocities of ball X and ball Y. The velocities of ball X is 31. Velocities of ball X and Y are 31.3 meter per second and 8.7 meter per second respectively. We are through. 1/3 way through. Okay, the second part of the question B. Let's do that one too. So I want to find when the two balls meet. So it's talking about time here. Don't you think so? Anytime we hear about when, means time should come to mind. Yeah, so we are trying to find the time here. We've already said that Tx is equal to Ty. Since they started at the same time and they met at the same time. Okay. So you can find either Tx or Ty to get the time the two balls met since they are the same. But from us solving on the other page, when we were solving on the other page, realize that Vx is equal to dtx sine theta. So let's try and make Tx the subject and see the relationship between Tx, d sine theta, and Vx. So making Tx the subject, we get Ts is equal to Ty. We know that it's equal to Vx over d sine theta. I hope you know how we made it a subject. So Vx is equal to dtx sine theta. To make Tx the subject, just bring Tx here. And Vx divided by d sine theta. Oh, good. So that's what we've done. Okay, let's continue. Let's continue with what they are doing. So now it becomes simple here because we've already found the values of Vx already. We've already found it. So okay, so 31.3 over 10 sine 35 degrees, that's the angle of inclination. What do we get? Tx is equal to Ty is equal to 5.45 seconds. Very good. So this is our final answer. I hope we are through. Good. Therefore, the two balls met 5.45 seconds after. Let's dive into the third part of the question. Where the two balls meet. Where the two balls meet. Where they met. Okay. So yeah, we're going to use the third equation of motion because that one will help us. But you might be asking, it could be seen clearly from the question that they met at a point P. So why are they asking us this question again? Physics is not just like that. They want you to do some solving, find something. So what do you think they want us to get here? Where you want us to find the distance from one point to another in the two balls met. So let's look at this one. So we'll use Sx, which is the distance traveled by ball y. The distance traveled by ball y. Okay. U squared, v squared s is equal to u squared x 2ss d sine theta. This is the third equation for motion on an inclined plane for downward motion. But ux is equal to 0. So let's put that in our equation. Let's substitute all the values we have. So we've already found out that Vx is equal to 31.3 and we are squaring it. So let's do that. Good. So 3.31.3 squared is equal to 2sx 10 sine 35 degrees. Sx is equal to 31.3 squared over 2 times 10 sine 35 degrees. We have made Sx the subject. How did we do that? So these people are worrying us. We send them to the other side to divide since they are multiplying here. So that's what we see here. Very good. Let's compute this value and see what we get. So Sx is equal to 85.4 meters. 85.4 meters. Therefore, the two balls met at the point P, which is 85.5 meters away from the upper edge of the plane. You remember our diagram when we visualized it. So this is it once again. So you see, we are saying that SS is equal to 85.4 meters. So where the two balls met is point P. And the distance between point P and the upper edge is Sx. And we found that that is 85.4 meters. So that's where the two balls met, 85.5 meters away from the upper edge. Someone can decide to come and find this one, but basically if you find this one, it's okay. You're good to go. Okay. Thank you for watching. If you have any question, ask in the comment field. Bye bye.